Now, this is a really big year if you're a developer, and we're launching the JavaScript 4.0 API. It's been in development for quite some time, and the way that we refer to it is it's the JavaScript API reimagined. We've taken a lot of the ideas that we've learned over the years, thought hard about it, redesigned the API to make it consistent across the entire surface, to make it very consistent if you're a 2D map developer or you're a 3D scene developer. We're making it easier for you to integrate it in with other JavaScript frameworks as well. And also, we've been working on making it mobile first. What does that mean? It means the design of the widgets work great on mobile devices as well as the traditional desktop browsers. So what I'd like to do now is pass over to Jan Cabon from the JavaScript development team, and he's got a series of demos to take us through the new 4.0 API. Jan.
Thank you, Ewan. So while you were developing with the 3x API for the last 2 years, we have been building the 4.0 API that is already powering the web scene viewer. And I want to go through a couple of, well, a couple actually, 17 tabs of examples showing new features and new coding patterns that this API introduces. So first, this is a very simple map, just with a graphic. It's one of, could be one of our samples. And to produce that map, I've created a graphic first, actually, with a point, geometry, and a simple marker symbol. Here, what I want to show you is that you don't need to remember what is the order of the parameters to create the instances. You don't have to remember that. You just pass an object with everything in it, as well as, you know, the order here also, but as well as we know that the outline of a simple marker symbol is a simple line symbol. So we do the work for you to actually create the instance internally. What it means is that you have way less modules to import and makes your code much more simple. Now I've created my map with a National Geographic base map, and one of the big changes also in 4 is the introduction of map view and scene view as in the Quartz runtime APIs. The map view is sorry. The map is actually the model of all your layers, and then the map view is what actually draws the map on the screen. So you create a map view with a map and a container, the properties like center and zoom, and then I pass just my graphic. And here my graphic is also automatically converted inside the map view. So if I have one map view for one map, I can also create, for example, a map with multiple map views. So in that case, I see the contiguous USA, and then I have 2 extra map views for Hawaii and Alaska. And actually, they are interactive, so I can pan around. And to achieve this, I've created once my map with my base map and my dynamic layer, as well as my first view with a specific center and scale. And I've created 2 extra views, one with the Alaska and one for Hawaii, where I changed the center and scale as well as the rotation to fit better into my little space. So all of these big changes, you can discover them through the brand new SDK. It has been redesigned both as designed, but also on the content. All the content is brand new. You have new guides, new API reference that is quick searchable, normally. And then brand new samples code. So I invite you to discover it when we release the API. So the map view is one thing, but we also introduced the scene view. So I have the exact same map as before, but now I have created a scene view. So the scene view works the same way. You create a map, you create it with a map and its container, as well as now the camera. The scene view understands extent, center, scale, but camera is really what's drive under the hood, the scene view. And then I've created, I pass also my graphic. So 3D can be challenging in terms of navigation. It's also challenging in 2D when you get a bunch of features coming from a query you just performed. You have to compute what is the extent and everything. So we introduced in 4 a new method called goTo to be able to quickly to go quickly where you want to go. So in that case, I just want to rotate my view when I click on those buttons to rotate around this, this mountain, or I want to change the tilt of my camera. So I just have to get the current heading of the camera, change the heading, and just call go to, and then all the work is done for me under the hood. 3D also has some interesting capabilities like environment. The environment defines the lights and shadows of your scene view, and you can also define the time of the day. So based on the time of the day and the day of the year, you can see basically the stars and also the sun position. So here we are in Brest, where I come from in France, and we have the castle of Brest at the bottom, but then when I change the time of the day, it also rotates the star. Well, rotates the Earth, right? The scene view can be, the scene view can also display local and projected data. It's great if you want to have this fishbowl type of experience. This is a scene view that has like projected data with elevation and also features. I can define the clipping area like Russ showed previously to just clip what I want to see. And then after I can easily like tilt my view to access the features that are underground. In this case, these are earthquakes, and then when I click on them, I can have the pop-up. In 4, we have made some concepts that are already in the API, new classes for them to make easier to work with them as developers. So like the new base map class. So to define this base map of the Arctic Ocean using the new Arctic Ocean services, I created a new base map with a thumbnail URL so that my base map toggle here can pick it with the base layer. So this is the bottom, and then the reference layer. To assign this base map on the map, I just assign it directly. The map understands well-known base maps, like it's like in 3x, like topo and streets, for example, but you can also assign new instances like this. A great way also to organize your visualization is to create group layers. Groups layers together, and then you can also define the visibility of each individual layers inside it, and define how the behavior changes. So if I toggle a layer here, the other ones are toggled off. But I can change the behavior to have independent layer visibility. To create that first group layer, for example, I created a group layer here with its title for my TOC to catch it, and then visibility mode exclusive, meaning that only one layer in that group can be visible at once, and then a suite of layers. One of the capabilities that we already have in 2D is to display raster images and perform analysis client-side. The image layer fetches data in binary format and actually goes through it and draw every pixel. And you can define that function that draws the pixels and choose the color for it. But it can also filter out data. So in this case, I'm visualizing sea temperature. And then if I change if I move my slider, I can filter out the temperature I'm not interested about. And this is all redrawn client-side. So there is no extra request to perform those changes. It's pretty awesome. We introduces also the new ArcGIS elevation layer that allows us to display elevation client-side, but we can also like perform very fast analysis, like a line of sight. So if I just click here, let's say, and then I drag my cursor, I have a line of sight of what I can see, right? But I can go also like do a profile, for example. Yep. This is not the most accurate profile, but it gives a very great user experience. So. All right. What is great with the JavaScript API is also to be able to get your features down to the web browser and also style them directly on the browser, so to create very appealing visualization. This one shows trees, and the trees are sized, the marker that represents the trees are sized with the size of the canopy of the tree, and then the color is changed based on its capacity of storing carbon. So to define this, I've created my simple marker symbol, and I want to create a renderer with a visual variable. So the first one is a size info, where I size the size of the tree based on its width, and also the color based on the carbon storage. I've defined my min and max value, and as well as the two colors. And I create my renderer that I assign to the feature layer. What works in 2D works also now in 3D. So the main benefit of 3D here is that I can take advantage of the extra dimension to size, for example, the trunk, as well as the canopy, and the canopy can be sized in height and width and depth. So I've created my point symbol 3D with a sphere, and then this is for the canopy, and then I've changed its height, width, and depth, and then the color info, as in 2D, same exact values. And I've created my simple renderer for my tree layer here. And finally, if I want some more realistic look, I can use directly 3D models of trees. And this is using a simple unique value renderer with different unique value infos, one per tree species. And based on this, the tree will be sized as well as well, the tree will be changing based on these species and sized based on the exact same attribute as before. So with the web scene viewer, you can author web scenes. But with the brand new Portal API, you can bring those web scenes down to the client and actually work with them. So here I have designed a little app where I showcase the different slides of a web scene. So if I toggle through them, it changes the layer visibility, go to a different viewpoint, and then it's pretty nice to convey the information. And to do this, this is the new pattern that we introduced, the two new classes, the web map and web scene. And the web scene you created with Portal item ID. And then when the scene is loaded, I can access its slides, and for each slide, create a little image. And when I click on it, this is all I have to do to change everything. Just call slide, apply to the view, and it will go to the animate to the appropriate camera, change the time of the day, change the visibility of the layers. But so we have the web scene, but we have also the new web map class. The new web map class will much better than in 3x, where you can create a web map with an ID and now access its layer as it loads, and much better to work with it. So here I have a very simple web map where I store the bookmark of New York. I will go to New York. And then one of the brand new capability of the API is to be able to bring down to the client individual layers that I've saved as items in my organization. And all I have to do, so this is a beer versus wine layer that has been designed by Jeremy Bartley. And I just copy and paste this ID, and then I will just add it and show you the code. Right, so I've created my web map. And this is how I bring down a layer. I would just call layer from portal item. I pass down the item ID. I could also set the URL of my portal if it's not ArcGIS Online. And then when it's added, I can just add it to my map. And what is great here is that it brings down the renderer as well as the actual pop-up. And all of this has been done for me previously on ArcGIS Online. And now René Rubacalva will introduce us what the API can do to build great apps. Thanks.
Thanks, Jan. So first off, the pop-up experience has been completely revamped for 4.0. For example, if you try and open a pop-up near the edge of the map, it's going to go ahead and reposition itself so that it's always going to stay inside of the map area. That way it's consistent throughout. You can also dock the pop-up now. This way you can dock the pop-up to a location and still interact with your map without the pop-up being in the way. And the pop-up's also designed to be responsive. So if I were to change this map here from being landscape to portrait, it's going to go ahead and reposition itself to the bottom, which is the best location in this case. We've also added some enhancements to the pop-up so you can kind of enhance the pop-up with custom actions. So if I click on this tree data here, in the pop-up I have an extra button down here called tree photos. So the way you get that is you just define an action for your pop-up template, and then when you click on that button, you just do something with it. And in this case, what I would do is do a Flickr search for the tree types of the data that I clicked on. This is another more extensive application where I'm going to be using a custom actions on the pop-ups when I click on a river, a section of the river. And when I do this, I have a custom action that's going to calculate the nearby flow and put in a little tooltip in the custom pop-up based on the stream gauges that are nearby. So this one's pretty kind of cool. You can also use the geometry engine to add some real-time geometry analysis to your application experience. So in this case, I would imagine I'll drop a bottle in the middle of the ocean. And when I do this, I'm going to go to a geoprocessing service that's going to calculate the route that bottle will travel using our ocean current data. And then when on the client side, I'm going to animate the route, but in real time, I'm going to create a buffer around that route and then select the tide stations that fall within the buffer. So this is a really cool use of using the geometry engine to increase your application experience. We've also introduced enhanced widget experience for you. So the widgets have been completely redesigned, and that way they're a lot easier to use and style on your own. And one of the things that we've done is introduce what's called a UI container. So the UI container is really neat because it will help you have a consistent widget layout so that your widgets are always going to be positioned correctly. And what I've done here is I've highlighted the UI container area on the map. And when you create a map view, you can just tell it what the default components are that you want to have. And they'll all be positioned in some default location. And then you can also add additional widgets. And when you do add your widgets, you just add them to the UI and tell them that you want them in a particular position. And the application is going to go ahead and maintain the position of those widgets throughout its entire use. So that's a really good use to be able to have a consistent layout for your app. And one of the other things that we've done is made the widgets themselves a lot easier to style. So I took the same application I just showed you, and I've gone ahead and restyled it so that it kind of matches the data of my map. And you can do that by just updating, let me open the pop-up too, updating a few CSS styles. So you can, we've provided CSS class names that are pretty consistent, and they make it really easy for you to be able to style your entire application around your map. You can even take that a step further, and you could take your custom styled vector tiles and completely revamp the UI with enhanced UI experience, so you could theme your whole application to your vector tiles. So in this case, we're going to go Lakers, right? So you can completely brand your entire application. Another part of the widget story is the introduction of the view models. So the view models are really cool because they're the workhorse behind all of the widgets in the API, and they have all the business logic available for you. So you can integrate them with other frameworks and completely create new UI experiences. So this example here is the zoom view model, and the zoom view model is pretty simple. It has a couple of methods, zoom in and zoom out. And what you can do, we're going to help you out here by providing the source code for all the widgets in the API. So if you go to like the zoom widget here, and you click on zoom.js, we're going to give you the source code for the widgets that we're building so you can see how we're using the view models, and you can use that as a guide to build your own widgets to completely redefine the application. This sample here, what I've done is I just went ahead and I'm using a framework called React to create a completely new widgets over here on the left-hand side. And it's pretty simple to do. I just integrate the view models with my React components like I normally would, and I'm able to just compose them together and build a brand new widget experience. So you could use a use case for that is if you want to build, say, your application to be mobile-based, and you want to focus on having mobile-friendly widgets. So I want my zoom and my compass to be more thumbpad-friendly. You could do that as well. And it's pretty easy to do because you just create your components the way you would with your framework of choice, and then you can even add those components to the UI container so that the layout's going to be consistent throughout. Something else we've introduced this past year has been some build and optimization tools to help you out a little bit more. So you can still use the CDN for development purposes, and you can use the web optimizer. But we released the API as a Bower repo not too long ago, and by using that repo, you can do custom builds of your entire application. The Bower repo is also going to contain the source SAS files that we use for the CSS in the API, so that you can go ahead and you can update those SAS files on your own, integrate them into your current build workflow, and you have full control to do custom local builds of the API and your application. And with the right tooling, you can get down to having a single JavaScript file and a single CSS file. So with all the API enhancements and the widget experience, the ability to integrate with other frameworks and the custom build tools, there's no excuse for you to not build great apps.